second one is to determine the volume and density of glass block. The apparatus that I used in this experiment is vernier caliper, micrometer screw gauge, weighting scale, ball bearing and glass block. At vernier caliper, there are jaws for measuring inner dimension, jaws for measuring outer dimension, vernier scale and screw clamp and main scale, and also stamp for measuring depth. And at the right of the image, we have micrometer screw gauge, and the component there are anvil, spindle, datum line and central line, main scale, thimble scale and ratchet. For the procedure for micrometer screw gauge, first, any zero errors were determined, and the second, the diameter of the ball bearing was measured. Third, step 2 was repeated at least 3 times at different positions of the ball bearing. Number 4, all data were recorded in the suitable table. And number 5, the actual diameter reading taking into consideration the zero error obtained earlier was calculated. Number 6, the weight of the ball bearing was determined. And last, number 7, the density of the ball bearing was calculated. For vernier caliper, the first is the whole number of small divisions were counted on the fixed part of the caliper that are to the left of the zero mark of the vernier. This gave us the size of the object to the nearest number of whole millimeters. The second one, the first mark at the vernier that lined up with one of the marks on the fixed part of the caliper was found. The zero area of the vernier caliper was determined. The length, width and thickness of the glass block was measured by using vernier caliper. And number 5, step 2 was repeated at least 3 times at different positions of the glass block. Number 6, all data were recorded in the suitable table. Number 7, the actual measurement was calculated by taking into consideration the zero error obtained earlier. And number 8, the weight of the glass block was determined. And last but not least, number 9, the density of the glass block was calculated.
Bismillahirrahmanirrahim. My name is Nurdin Muhammad Arabi. I'm from group R-1201A. So here this is the result from the experiment 1. To measure the diameter of the ball bearing using a micrometer screw gauge and to determine its volume. The formula to calculate the value V is V equals to 4 divided by 3 pi r power of 3. The value for zero error is 0.00. So here this is the table for observed reading. First atom, second atom, third atom, and the average of all the atoms. For the average, for diameter of ball bearing is 19.02 millimeter, and the average for radius of ball bearing is 9.510 millimeter. This is the table for true reading. The average for diameter of ball bearing is 19.02 millimeter, and the average for radius of ball bearing is 9.510 millimeter. To measure, the formula to calculate the value V is V equals to L length multiplied with width multiplied with 8. The value for zero error is 0.00. So this is the result from the analysis. We use all the formula that are different. For ball bearing, we use two formulas. First one is V equals to 3 divided by 4 pi r power of 3. The final answer is 2030.543 millimeter cube. For the second formula, we use total of V equals to N bracket total of R radius divided by R bracket V. The final answer is 6.402 millimeter cube. For the glass block, we use volume V equals L multiplied by W multiplied by H. L is length, W is width, and H is height. The final answer for V is 174.6252 centimeter cube. The second formula that we are used in this analysis is total of V equals to bracket total of L length divided by length plus total of width divided by width plus total of height divided by height bracket V. The final answer is 2.55324 centimeter cube. So the density, the final answer for density is 0.1088044.566 gram.
And for this discussion of this experiment for positive and negative error, when the jaws are closed, the zero mark at the vernier not coincides with the zero mark on the fixed main scale. Positive zero error means if zero error point on the vernier scale is to the right of the main scale, this is called a positive 0-point error. The zero correction should therefore be subtracted from the measured value. And negative zero error means if the 0 point on the vernier scale is to the left of the main scale, this is called a negative 0-point error. Therefore, the zero correction should therefore be subtracted from the measured value. Parallax error. A parallax error is an error in reading an instrument due to the eye of the observer and pointer are not in the line perpendicular to the plane of the scale. For accurate measurement, make sure the position of eyes was perpendicular with the scale of caliper. This is to avoid parallax errors which will give rise to inaccurate measurement. 3 random errors. When repeated measurements of the quantity yield different results under the same conditions, this is referred to as random errors. And moving on to the next point is the conclusion. The conclusion for this experiment could consider success as we had get the measurement of length, width, and height. We can conclude that vernier caliper is the most suitable tool to use to get the accurate measurement, as it have 2 scale, which is the main scale have 1 decimal places and the second scale in vernier scale have 2 decimal places. Other than that, we can calculate the volume and uncertainty by measuring the length, width, and height by using the formula of length times width times height. We can get the volume of the rectangular object. To get the volume and uncertainty, we need to use this formula equals to uncertainty, length plus uncertainty width plus uncertainty divided by height times volume. The volume of rectangular object with uncertainty is 8.448 times 10 raised to the power of negative 8, m raised to the power of 3 plus 3.808 brackets 3.08 808 times 10 raised to the power of negative 7 meters. That's all. Thank you.
The objective of this experiment is to verify the accuracy of Hooke's law, and the apparatus that we used in this experiment is helical steel spring with a supporting stand and scale, set of slotted weight with hanger, and weight balance. The procedure is measure and record mass of the hanger, and second, calculate weight of the hanger and record SW in the table. 3. Adjust the scale so that the pointer of the hanger is near the upper end of the scale where the hanger is unloaded. Record its position as X0. And the fourth one, load the hanger by 10 gram mass. Record the scale reading. Next one, keep increasing the load by suitable increment. They need to be equal to obtain 8 data points before the lower end
The
of the scale
analysis
is reached.
for the experiment 5.
Record all data,
There
which
is
mean
5
W and
analyses,
X.
and this is the first one.
Number 5.
Plot the
Reverse the
graph of
process
the
by
force
unloading the
causing the
same loads
extension
as
F
in
to
3.
get the extension
Again,
X.
record new scale
Calculate
reading
gradient of the
X2
graph.
for each load.
What value does
And
the
number
gradient
6. Calculate extension of the
represent?
spring, which means
So here this is
the
the
number of X.
graph
All the number of X. The sum of
force
X.
causing the
And
extension
the
F
last but not
against the
least, number
extension
7.
X.
Determine the extension force acted on the spring F for each
To
total
find
loads.
gradient, we use formula gradient equals to y2 minus y1 divided by x2 minus x1. The final answer is 0.0375 Newton per meter. For the second answer for analysis is how much done work in stretching the spring through 0.20 meter. Find this from the graph. We use formula for work equals to area under the graph. Half multiplied by 0.98 multiplied by 0.20. The final answer is 0.098 Newton per meter. Rahim. My name is Aidil Marafi. I'm from Pro RAS 12018. So here this is the result from the experiment 5. Scale reading without load X0 equals to 0.18 meter. The hook weight is 10.20 gram. The table 6.1 is the experiment data for the experiment 5. If there is a loaded mass M in kg, total mass of loaded mass and hanger also in kilogram, weight of loaded mass and hanger in Newton, extension force in Newton, scale reading with load in meter. For the scale reading, there is 2 trial and average. There is 2 trial and average for the scale reading for each of loaded mass. After that, the last one is extension of the spring. Extension of the spring, we use formula total of X equals to X1 minus X0. The final answer in meter. The third answer of analysis is how much energy stored in the spring when it is extended to 0.20 meter. We use formula F equals to Kx. After that, K equals to F divided by X. The final answer is K equals to 4.9. After that, we use energy formula. If energy equals to half Kx power of 2. The final answer is 0.098 joule. For the question 4, analysis, describe any errors that may have occurred during this experiment. So here there is 2 errors. The first one is systematic errors on the instruments in the experiment. The second one is inaccurate measurements while doing the experiment. For the last one of the analysis is what can you describe for your result about the relationship between the extension of a spring and the force closing extension. Force directly proportional to the extension of a spring, which means the larger the force applied, the bigger the spring will extend.
And now for the discussion of this experiment, shows the result of the experiment would then prove the theory of Hooke's law, and that gives us the idea of this law. It also shows that some examples in our daily life by using this Hooke's law, like tying a rubber band in construction works and even indoors that we are using. The experiment shows that obtained results tells us about Hooke's law by showing that after adding masses, it would then return to the spring's original length because it's stated in Hooke's law. For relatively small deformations of an object, the displacement or size of the deformation is directly proportional to the deforming force or load. This experiment also contains some of the errors as example, some systematic errors on the instrument in the experiment, and inaccurate measurements while doing the experiment. This could be improved by using a much more accurate instruments and by having precautions before doing this experiment. And next would be the conclusion for this experiment. The conclusion of this experiment shows the accuracy of Hooke's law was achieved in this experiment. This is because, as what the law states, the results would then be obtained by adding and removing of the masses. It shows us the original length of the spring before and after adding and removing the masses would then return to its original state. That's all for now. That's all from me. Thank you very much.